Numerical solution of ordinary differential equation, Euler's method. Differential equation of Euler's method, it is given like this: dy by dx is equal to f of x comma y, and initial condition it is given y of x0 is equal to y0. So actual solution of this differential equation, it is p0 comma x0 y0. So this lies, it is on the curve. We require value of y of the curve at x is equal to x1. So we have to find the equation of y in terms of x1. So for this we have to take the equation of tangent at a point x0 comma y0. So equation y minus y0 is equal to y dash of x0 comma y0 into x minus x0. Now this y dash you have to replace with f of x0 comma y0. So equation becomes y minus y0 is equal to f of x0 comma y0 into x minus x0. Now this is a negative sign, so you have to take this negative sign towards the right side of this equal to sign. So equation becomes y is equal to y0 plus f of x0 comma y0 into x minus x0. This is the value of y on the tangent corresponding to x is equal to x1. The value of y on the tangent at x0 comma y0 corresponding to x is equal to x1 is given like this: y1 is equal to y0 plus f of x0 comma y0 into x1 minus x0. This x1 minus x0 it is called as the interval, and this is denoted by h. So h is equal to x1 minus x0. So from this we can write the formula of y1. So y1 is equal to y0 plus h into f of x0 comma y0. So from above equation we can write the y2. y2 is equal to y1 plus h into f of x1 comma y1. From above these two equation we can write the iteration formula for Euler's method. It is like this: yn plus 1 is equal to yn plus h into f of xn comma yn. Values of n, it should be start with 0. So n is equal to 0 comma 1 comma 2 and so on. Now for this Euler's method we will see one example. Solve dy by dx is equal to x plus y plus x into y. Y of 0 is equal to 1, taking h is equal to 0.025 at x is equal to 0.1. Now step number 1, we have to write what is given. So dy by dx it is given. So I can write in this way: dy by dx is equal to f of x comma y is equal to this equation it is given. So x plus y plus x into y. Then initial condition it is given: y of 0 is equal to 1. So y of 0 is equal to 1. So I can write in this fashion: y of x0 is equal to y0. Now compare both the equation. So from this equation we can find the values of x0. So x0 is equal to 0 and y0 is equal to 1. After this, see here h it is given, value of h it is given. So h it is interval. So h is equal to 0.025 and we have to find the value of y at x is equal to 0.1. Now see what is the meaning of this. So first I can draw one line. Within this line I can take here x0, x1, x2, x3 and x4. So h it is the interval in between x1 and x0. This is h, it is 0.025. Again x2 and x1 it is a h, it is 0.025. x3 and x2 it is 0.025 and x4 and x3 it is again 0.025. Now how to find the values of x1, x2, x3 and x4? So x0, value of x0 it is 0. x1 it is, this value it is 0.025. Then x2 it is a summation of 0.025 plus 0.025 up to this. So summation of this and this, it is 0.050. Then how to find the x3? So x3, this is the x3. So 0.025 plus 0.025 plus 0.025 we get here 0.075. This is the x3. How to find the x4? So total summation of all these 4, so it becomes 0.1. Below x0 I can write here y0. Below x1 I can write here y1. Below x2 I can write here y2. Below x3 I can write here y3. And below x4 I can write here y4. So after finding all these values of x1, x2, x3 and x4, we have to find the y4. How to find the y4? See here what is the meaning of this. So you have to find the y4 at 0.1. See here, we have to find the value of y at x is equal to 0.1. So within this Euler's method, we have to do the iteration up to the y4. So you can write the formula yn plus 1 is equal to yn plus h into f of x n comma yn, n is equal to 0, 1, 2. So first iteration number 1, you can put the value of n is equal to 0 in this above equation. So n it is 0, so y1 is equal to yn, so n is equal to 0, y0 plus h into f of xn comma yn, so value of n it is a 0, so it becomes x0 comma y0. Now to find this function f of x0 comma y0, so what is given here, f of x comma y, it is given f of x comma y is equal to this equation, it is given, so x plus y plus x into y. Now we have to find the f of x0 comma y0. So for this equation you can add only, for this above equation we can add suffix 0, so f0 here y0, so x0 plus y0 plus x0 y0. So all the values are known. X0, you can say x0 it is 0, x0 it is 0, y0 it is 1, plus x0 it is 0, 0 into 1, so final answer for this it is 1. Now this one you can put in this equation, so y1 is equal to y0, so y0 it is 1, so 1 plus h, it is the interval, it is the same, so it is 0.025 into 1, so y1 becomes 1.025. Then we have to find the second iteration. So for this you can put the value of n is equal to 1 in above equation. So it is n, it is 1, so 1 plus 1 it is 2, so y2 is equal to here yn, it is y1 plus h into f of n, it is 1, again here it is 1, so f of x1 comma y1. Now we have to write the equation f of x comma y1 is equal to x plus y plus xy. Now we have to find the value of f of x1 comma y1, so suffix you can add here 1, so it becomes f of x1 comma y1, so equation changes to x1 plus y1 plus x1 comma y1. All the values are known, so x1 it is 0.025 plus y1 it is 1.025 plus x1 it is 0.0205 plus y1 it is 1.025. Solve this, we will get here 1.0756. This you can put in this equation here. So y1 it is 1.025 plus h it is 0.025 into 1.075. Solve this, we will get answer for y2. So y2 it is 1.0518. Then you have to find the third iteration. So n is equal to 2. So our equation. So equation becomes y3 is equal to y2 plus h into f of x2 comma y2. Now again we have to find this function. Again we have to find this function f of x2 comma y2. So again we have to write the equation what is given, f of x comma y is equal to x plus y plus x into y. So we have to find the function of x2 comma y2. So suffix you can add here 2. So f of x2 comma y2 is equal to x2 plus y2 plus x2 into y2. All values are known. X2 it is 0.050 plus y2 it is 1.0518 plus 0.050 into 1.0518. Make a summation of this. So it is 1.154. Put this value in this equation. So y3 is equal to 1.0518 plus h it is 0.025 into 1.154. Make a summation of this. So y3 it is 1.0806. Now we have to find the fourth iteration. So n is equal to 3. So above equation you can put the value of n, it is 3. So y 3 plus 1 it is a 4. Yn it is a 3, y3 plus h into f of n it is 3. So x3 comma y3. Again we have to write the equation of f of x comma y is equal to x plus y plus x into y. This is given. Now we have to find the function of x3 comma y3. So suffix you can add here 3. So x3 comma y3 is equal to x3 plus y3 plus x3 into y3. All values are known. So x3 it is 0.075 plus y3 it is 1.0806 plus x3 t is 0.075 into y3 t is 1.0806. So do your multiplication, again summation here. So answer it is 1.2366. Now this value you can put in this equation. So y4 it is, y3 it is 1.0806 plus h it is 0.025 into 1.2366. Here you can do the multiplication and you can add this value. So y4 is equal to 1.1115. So this value it is y at x it is 0.1. So value it is 1.1115. Thank you for watching video.